On August 15, 1977 at 10:16 p.m. a radio telescope in Ohio picked up a signal from deep space. It lasted exactly 72 seconds, then it vanished, and in nearly 50 years it has never come back. Tonight, we're going to trace that signal to its source. You'll see why it was 30 times stronger than anything the sky should produce. Why every explanation we've tried has failed. And why, in 2022, astronomers finally found a star, almost identical to our sun, sitting in the exact spot the signal came from. Stay until the end. Because the most unsettling part of this story isn't the signal itself. It's the silence that followed. This is the Big Ear, a radio telescope the size of 3 football fields, built from aluminum and Ohio farmland. By 1977, it had one job: listen for anyone out there. It scanned the sky at a very specific frequency, 1420 MHz, the hydrogen line. Hydrogen is the most common element in the universe, and it hums at this exact frequency everywhere, in every galaxy. If an intelligent civilization wanted to be heard, this is the channel they would choose, a frequency every astronomer in the universe would know. The telescope ran automatically, printing columns of numbers onto paper, ones, twos, mostly blanks. The quiet static of an empty sky. Every few days, a volunteer named Jerry Ehman would collect the printouts and scan them by hand, line by line. On August 18th, 3 days after the observation, he was doing exactly that at his kitchen table. Then he stopped. Running down the page was a sequence he had never seen before. 6, E, Q, U, J, 5. These characters measure signal strength. A 1 is a whisper, a 9 is a shout. Beyond 9, the computer switches to letters. That U in the middle? 30 standard deviations above the background noise. The loudest thing Big Ear had ever recorded. Ehman grabbed a red pen, circled the sequence, and wrote one word in the margin. Wow. Here's what makes those 6 characters remarkable. The signal didn't just appear. It rose and fell in a perfect curve, peaking exactly at the center of the 72-second window. That's precisely what a distant, fixed point in space should look like as the Earth's rotation sweeps the telescope's beam across it. A signal from Earth, a plane, a satellite, a stray transmission, wouldn't do that. It would jitter. Cut in and out, drift. This didn't. It behaved like it was coming from the stars. And it was narrow, less than 10 kilohertz wide, a laser-thin spike on the dial. Nature is messy. Gas clouds and dying stars smear their noise across the spectrum. A signal this clean, this focused, on the one frequency the whole universe shares? That's not what chaos looks like. That's what a broadcast looks like. So they looked again, the same patch of sky in the constellation Sagittarius, toward the heart of our own galaxy. Nothing. Ehman and the Big Ear team re-scanned it for weeks. Silence. In the 80s and 90s, astronomer Robert Gray made it a personal obsession. He used the Meta Array, then the Very Large Array in New Mexico, one of the most powerful radio observatories on Earth. More than 100 follow-up searches, not one echo, and decade by decade, the ordinary explanations died. A military transmission? The hydrogen line is internationally protected. Nothing on Earth is allowed to broadcast there. A satellite? None were in that part of the sky, and the signal's motion matched the stars, not an orbit. A telescope glitch? The hardware checked out, and a glitch doesn't rise and fall in a perfect celestial curve. Then in 2017, a scientist named Antonio Paris offered something new: 2 passing comets, wrapped in clouds of hydrogen gas. For a moment it looked solved. It wasn't. Astronomers checked the orbits. The comets weren't in the beam that night. Comets don't emit strongly at 1420 MHz. And the explanation collapsed under one final detail we haven't told you yet. Big Ear had 2 beams, 2 separate windows on the same sky, minutes apart. The signal appeared in only one of them. Whatever it was there when the first beam passed and gone before the second arrived. In under 3 minutes, it either shut off or moved. For 40 years, that's where the story froze. A 72-second scream from the dark, and then nothing. Then, in 2022, an astronomer named Alberto Caballero tried something no one had done. He took the signal's coordinates and cross-referenced them against the European Space Agency's map of over 1 billion stars, asking one question: if someone sent this, where would they live? One candidate stood out. A star catalogued as 2-mass 1928, 1800 light-years away, and it is almost a twin of our Sun, same temperature, same size, same class of star that we know can host planets like Earth. It sits in the exact region the WOW signal came from. That same year, the Breakthrough Listen project pointed the Green Bank telescope, the largest steerable radio dish on Earth, directly at that star and listened. But think about what that distance means. If the signal really came from there, it left that star 18 centuries ago, around the time the Roman Empire was collapsing. A civilization that sent it could have risen, flourished, and died, and we would have no way of knowing. The reply we send today would take 1,800 years to arrive. So what was it? A rare natural flare from a cloud of cold hydrogen? As one recent study suggests? Maybe. But no one has caught the sky doing it again. An alien broadcast that swept past Earth for 72 seconds, One rotation of a distant beacon, like a lighthouse beam crossing a ship at night? We can't rule it out. Jerry Ehman himself spent decades trying to explain it away, and admitted he couldn't. Here's the detail that should keep you up tonight. We only heard it because, for 72 seconds, one telescope in Ohio happened to be pointed at exactly the right spot. Big Ear could see 1/1,000,000th of the sky at a time. If the universe sends messages like this, how many have we already missed? The signal came once. We've been listening ever since. And the sky has never said another word. Every 22 minutes, a signal from deep space has been striking the Earth. And it's been repeating for 35 years. That's next time, on Kelvin Zero. If tonight's silence left you with questions, subscribe. The universe is cold. We keep watch anyway.